Hello and welcome to our course on software quality. My name is Jaak Tepandi and this is the first video which gives a short summary of materials we discuss on lectures, exercises, and we work on the labs. The main materials for this course are on Moodle in the course Software Quality, Tarkvara Kvaliteet, alternate download on tepandi.ee. Before I proceed into more technical and detailed discussions, let's ask, what is software quality? In a recent forum about failed large software system, one of the developers said that there is no such thing as software quality. There is permanent speed, new projects come up, there is no time to test your previous projects enough, so software quality does not exist. Let's see how we see it. First, we can notice that quality of anything, any product, including software, is not absolute. The same thing in different environments may mean absolutely different quality to interested people. For example, water in a desert has absolutely different quality than water when you are sitting at a lake or swimming. So what is distinguishing? The product is the same, but its quality is different. The difference is that the requirements in different situations vary. So that's why we say that the quality depends on requirements. ISO 9000, a quality management standard, defines quality as degree to which a set of inherent characteristics of an object fulfills requirements. So quality is relationship between product and requirements. For a complex product such as software, we typically do not have enough resources and time to check conformance to all requirements. This check may be very complex. So we need to know how this product was developed. We need to know the process. This includes processes, requirements, and product in our notion of quality. Software is not unique in this respect. The same refers to food, medicines, cars, airplanes, and many other things. Now, coming back to this developer's remark about non-existing software quality, we may notice that there are different notions of software quality. We may refer to software quality as an ideal, so something very high to be achieved, almost impossible to achieve. We may refer to software quality as a relationship or conformance between product, requirements, and processes. And we may refer to software quality as a measure. We can always assign some measure. For example, if the quality is very low, then the measure might be 1 on a 100-point scale, or if the quality is high, it might be 90 on a 100-point scale. If we now ask what the meaning of this statement was, probably this developer was referring to the quality as an ideal. And yes, it's very probable that most software products do not satisfy this requirement of quality as an ideal. But still, we can talk about quality as a conformance to requirements, and this is the viewpoint we take in this course. Or we can talk about quality as a measure, which is also to some extent considered in this course. In the last case, quality is always present, it's just maybe very low. So different notions of quality, 3 notions. Now let's also note that quality is a trade-off, because we always have constraints for our software. It's constrained by budget, it's constrained by time, it's constrained by requirements. So this project management triangle says that you can achieve 2 of these, but not all 3 together: price, speed, and quality. Well, so these were some basic notions about quality. You can say that quality is relative. Quality includes 3 components, 3 main components. Quality has different notions, and quality is a trade-off. Now let's proceed to the first component of software quality, so software product. If you ever have had a situation where your luggage didn't arrive, you need to spend a week in a foreign country where it's cold and you don't have anything to wear, and you are told that there was a software problem. You might have thought, what does this mean? What is a software? What is software problem? Putting aside the possibility that this was just a kind of buzzword or claim made to say anything, let's ask, what is behind the software product? A definition from international standards says that software product is a set of computer programs, procedures, possibly documentation and data. We also include many other things into the software product, such as licenses, to some extent knowledge, to some extent work processes in an organization, and so on. At least they are related, and if we talk about quality, we need to talk about these things too. But let's have a look at what is in a software system or in a computer system besides the software. Well, here is a picture. We have the target software here, and mostly when talking about software quality, we are referring to quality of this target software. And so this is the product quality we are talking about. But as in the case of this luggage that didn't arrive, actually the problem may be in very, very different components of this target computer system. There is non-target software. There is hardware. There are communications. There are target data. There are non-target data. And all these components may be sources of failures, such as missing luggage. We have different stakeholders who work with the system: users, administrators, maintainers, developers, other systems that our target system interacts with. And errors may come from all these sources. Respectively, when we talk about quality, we may refer to product quality. We may refer to quality in use, which means value of this system for the users. And we may talk about data quality. We may also refer to the process quality, if we look back at the overall schema of the quality components. This was just a little bit more complex picture than just software. Now, complexity is introduced by many other components. There may be levels of complexity associated with our target computer system because of different semantics, organization, and legislation. If we have just one system in the same organization, then the semantics, organization, and legislation are the same. But in case we have different systems in different organizations, different countries, we may have different computer systems with different semantics, organizations, and legislations. And this increases the complexity much more. As in the case of this airplane system handling luggage, the problem might be in any of these layers of complexity. So, finalizing the key points to know. We have 3 components of quality. We have 3 different concepts of quality. We know that quality is relative. We know that quality is trade-off. We have 4 quality models. We know what it means to speak about software as a product. We know how the software is incorporated in a system. What are the other components? We know about target and non-target software, data, hardware, communications. And we know about layers of complexity or interoperability in our software. Thanks, and see you in lectures and exercises and labs.